We're live. We're live here in the Life Sciences building. I'm here with Jose Trujillo, right, Jose?
Yes.
Is that right? And he's a work study student here. He's a biology major, and we're going to talk Math 221, applied calculus. We're really testing out this flip video, see if it works. I've got a problem here, which is in R5, the end of the review chapter. It's Zipf's law. Zipf's law is a pretty cool, it's a weird law. It's not a law, it's just an observation. And it says that the number of cities in a country with a big population, with population exceeding a certain amount, is inversely proportional to that amount. So we want to work this thing out. Now I've collected some data from Wikipedia, and we're going to see if it's at all accurate using this data. So why don't we pick a city? What's a good big city? Not like New York. It's something sort of in the middle. Pick a big city.
What about Chicago?
Okay. And let's not pick something at the far top, just like a big city in Colorado, maybe.
Colorado Springs.
Okay. So let's try and pick Colorado Springs. So what we're going to do is we're going to try and test this out to see if it's accurate. So we are going to check out. This is, say, the question we're going to ask. How many cities in the U.S. have a population bigger than, we'll just say, like 1 million? And we're going to assume Zipf's law is true, and we're going to assume that we know. And what city did you pick?
Colorado Springs.
Okay, so we're going to assume that we know that there are blank cities with a population bigger than blank. Now, Jose, can you look up, find Colorado Springs on here, and tell me its population and its rank? I think the population of Colorado Springs should be in the 300,000 area, maybe 350. Is it listed there at all? 300,000, 350. Here's Colorado Springs.
Okay.
So what's its population?
399,827.
We'll go with 400. Is that pretty accurate? Okay.
Yes.
What was its rank?
Its rank is 46.
Okay. So we're going to pretend that we know this fact, that there are 46 cities with a population over 400,000. I guess technically it's 45, because technically Springs isn't over that. So does that make sense? Do we have that information from Wikipedia?
Yes.
Okay, so here's the weird thing. Just knowing this one fact, we are going to be able to estimate this fact. That's what Zipf's law says. If you know, okay. So let's sort of work this out. It says that the number n of cities with a population bigger than S is inversely proportional to S. So how would I write that it's inversely proportional to S, Jose? Do you know the difference between, should I write it as a multiple times S? Or should I say is that inversely proportional, or is this inversely proportional?
The second choice is inversely
Yeah, that's
proportional.
inversely. This is called direct proportion, right?
Yes.
And we're not going to be doing this in this problem. We're going to use this guy. Okay, so that's Zipf's law. And what we're going to do is see if we can plug in the known information into this. What's the known information? What's the information that we're saying that we know? How would that plug into this?
You would have your...
What's the N here? What's the number of cities we're talking about in this
45.
So we know that 45 cities have a population bigger than, we don't know what K is, and we're trying to figure that out. And what's the S here? What's the population level we're talking about?
400,000.
400,000. How would you solve this guy for K? What would K have to be here?
You would multiply by the reciprocal.
We want to clear out the 400,000, so we would multiply both sides by 400,000, right?
Yes.
Kill it off here. We have 45 times 400,000 is K. So that means K, if we had a calculator, we would know that's about 18 million. I hope I did that arithmetic right. I think I did. So K is 18 million. So now we know what K is. So the circled equation really is the following now. We really know what K is. So we don't have to leave it as K. We can write 18 million over S. So that's the equation that we got now. How is this going to help us? This is sort of the miracle of Zipf's law. How is that going to help us answer our question? Now that we know this is the equation to use, how are we going to figure out this answer?
By just plugging in our S, which is 400,000.
Well, if we plug in 400,000 in here, we'll get 45, because
Okay.
we already knew that fact. We want to answer this question. So what should we plug in for the S here? What's the population level we're curious about here?
1 million.
Yeah, so we're just going to plug in 1 million. And Zipf's law says that N should be 18 million over 1 million. So we're going to plug in that S equals 1 million. And what's 18 million over 1 million equal to?
18.
It's 18. So Zipf's law is going to predict that there are 18 cities in the United States over 1 million. So let's see how good Mr. Zip is.
2, 3, 4, 5, 6, 7, 8, 9.
Yeah, those are listed in order. So you're finding how many cities are over 1 million? Just 9, right? I think
Yes,
Dallas
just 9.
Is Dallas the 9th city there?
Yes.
Yeah. So unfortunately, that's the prediction of 18. It turns out N really is 9. So that's how Zipf's law works. It wasn't a super great prediction, but it was not bad.